This video is designed to show you how to conduct a factorial ANOVA using SPSS. In this example, our dependent variable is math achievement, and our independent variable is math grades. If students got less than A or B, and that's coded 0, and if students got mostly A or B, and that's coded 1. The Father's Ed levels is the other factor, and they're coded as if students had fathers who earned a high school diploma or less, they were coded 1. Students whose fathers earned some college were coded 2, and students whose fathers who earned a BS or more were coded 3. So as we do with all our factorial ANOVAs, is we go to Analyze, General Linear Model, and Univariate. And then in our Fixed Factors box, we're going to put in math grades, mostly A or B, or less than A or B. That's the two categories. And Father's Education levels revised. Make sure you use Father's Education revised. And in our dependent variable, we're going to enter math achievement. For our outputs, what we like to have is our plots. And so we're going to have math grades on separate lines because there's two categories of math grades across the 3 levels of Father's Education revised, which we'll put in the horizontal axis. And then we'll add that. And then we'll continue. In terms of post hoc tests, we want to, if the Father's Education revised levels are significantly different, we want to be able to tell which groups of students mean math achievement scores based on their classification according to Father's Education levels are significantly different. So we're going to use the Tukey test. And then for math grades, we don't need to move that into the post hoc test box because there's only 2 levels. And if that factor is significant, then all we have to do is look at the means to determine which factor is significantly higher or lower on mean math achievement than the other factor. And then we can click on Continue. Now under Options, I like to have display means for overall because that gives us the grand mean for the analysis. In addition, I like to have descriptive statistics, the estimates of effect size, observed power, and homogeneity tests. And then I want to click on Continue to run the analysis. So you can see we get our output, and make sure again that you check to make sure that you have the correct number of students who have less than AB and most than AB that agrees with your spreadsheet data, as well as the correct number of students whose fathers are had the differing education levels. Notice we get the means and the standard deviations. We get our Levine's test. We'll have to discuss this in class about how we might handle this violation because we see that our variances among groups are significantly different, and that's what this Levine's test shows us. And then we can see that our test of between subjects, we have our math grade factor, it's significant. We have our Father's Ed revised factor, and it's significant. But most importantly, we have the math grade by Father's Education levels factors interaction, which is also significant. So we can't independently interpret the other 2 factors by themselves. So what we have to do is a simple effects analysis to determine at what levels of Father's Education that students with mostly AB or less than AB differ in terms of mean math achievement. So that's what the next video will tell us.